Okay, so today we're looking at how voltaic cells work, also called galvanic. I have a few other videos on this, so if you needed more practice, there's some more you can check out. This is one example I would like to go over. So this one, we're just going to start with our cell notation. So this is telling us what we have in each of our half cells. So we'll have silver, Ag positive, copper, so 2 positive, and copper solid. So you still want to pick your strongest OA and your strongest RA. So if we go through this, you have the silver ion is right here and the copper ion is below it. So the silver ion would be your strongest OA, meaning it's undergoing reduction, and that would happen at the cathode, which would make this other side, copper, being your strongest RA, which would undergo oxidation, and that happens at the anode. So if I'm going to fill this in, I tend to write my anodes on the left-hand side. So I'd say this is my copper solid, and I'd have copper 2 positive floating around in solution. Then on the right-hand side, I would have my silver solid, and then I would have silver ions floating around in solution. Now, how our cell will always work is your electrons will float from the copper to the silver, meaning your anode to your cathode. And when that happens, copper is undergoing oxidation, meaning it's losing electrons. So copper solid becomes copper 2 positive plus 2 electrons. And when that happens, the ions go into solution. So your copper 2 positive concentration will increase, and the electrons move over and go into that wire heading over to silver. Now, with the copper 2 ions heading more into solution, we're going to get more positive charges in the solution. So from the salt bridge, where you have positive and negative ions, the negative part of the salt will come on down to neutralize that solution. The other part here with copper solid being broken up into its ion and the electron, it is going to decrease in mass and become smaller. Now on the other side, we have silver, and as the electrons come over and come onto the silver cathode, it will attract the silver ions that are in solution, and it will form silver solid. So we're going to have more solid coming and forming on this cathode, and the cathode will increase in mass. And as the silver is leaving the solution, it is getting less concentrated with silver ions. It's also leaving behind negative charges. So the positive cation from the salt bridge will move over to help neutralize that. Now, because your OA is higher on the table than your RA, just like before, this is a spontaneous reaction. This is also a voltaic cell, and all voltaic cells will be spontaneous, because as this reaction takes place, it will generate a voltage, and we will be able to calculate that on the next slide. So that is how our cell is working. Electrons always from the anode to the cathode. The negative ions will always head towards the anode. The positive ions will always head towards the cathode. The concentration at the anode of the ion in solution will increase, where at the cathode it will decrease, and then the anode loses mass and the cathode gains mass. With our next slide, to calculate your cell potential, so we already saw that the silver half cell is where we have the cathode, and the copper is where you had your anode. So when you're calculating cell potential in a very easy form, it's always going to be the potential at your cathode subtract the potential at your anode. So we're just going to grab those values from the booklet. So your cathode was a silver value, and so that is going to be positive 80. So we'll have 0.80, and then we're going to subtract the value of the anode, which is 0.34. So we'll just plug that into our calculator, right? Just double checking cathode and anode. And when we do that, which I should be able to do in my head, but let's just use this, we get a positive cell voltage of 0.46. So we do still know that it's spontaneous, which all voltaic cells will be. As always, I hope you found this helpful. If you did, please subscribe. And if there's any other video I could do for you, just let me know. Thank you for watching.